All right, welcome to our Lab 3 project demo. Unfortunately, this loud beeping is our project, so you're gonna have to bear with me for listening to me on the project. What it basically does is it manipulates this monotone audio output based on my inputs that goes through an ALU. So the first thing I'm gonna show you is the A and B. These first four are A, these next four are B, and then the following four, to make a total of 12, are the ALU select. The A and B is just 0, 0, 0, 0 for the ALU, so make sure this is all off. And you notice that if I select A, nothing happens. If I select B, nothing happens. But if I select A and B, then you get an output. Select two A's and two B's, you get an output. Nothing, nothing, output. All right, next one is A or B. You do that by flicking this one off for 1, 0, 0, 0. If you notice this, output, output, nothing changes when I select both. Nothing changes to turn A off. When I turn both off, it changes. So A or B. All right, next one is not A. This is flicked by 0, 1, 1, 0. To demonstrate this, you can see how when I manipulate A, there is a change in the output. But when I manipulate B, there's no change because it has no bearing on this particular output. All right, last one I want to demonstrate is A minus B. This is done by 1, 1, 0, 1, and that is A minus B. And the best way to show this is to set A to a very high value by flicking all A's on. This is going to produce the lowest volume. And you notice when I select B to a relatively high input, then you're going to get a very loud volume as shown here. All right, thank you. That should be everything. Oh, that's some glitching. All right, thank you.
Yep. Okay, in our lab 3, we use speaker with PMW signal as our output. For each clock cycle, the PMW wave is produced using a counter. The duty cycle of the PWM, which indicates the result of amplitude, is determined by the percentage of ones in the final signal. Our initial goal was to generate Morse code-like sound for sequential binary numbers. However, we encounter some issues with this initial approach. In our initial approach, we integrate a state machine to enable the speaker to interpret zeros and ones over varying time intervals. During the phase, we realized that representing each bit with a distinct frequency might be more efficient. However, we also encountered the challenge in achieving the correct combination of the ALU output, so we start to simplify our method. In our new approach, we decide to modify the output, so it varies only in amplitude controlled by the duty cycle using a set threshold. Jackson will further elaborate on our methodology.
All right, so in this program, PWM out is the pulse width module, which produces a square wave where the high values correspond to the frequency being constant. Threshold, which is unique to our program and is, well, not that unique, but is calculated using the result, which is directly brought in from the ALU. This threshold is essentially going to calculate what percentage of a clock cycle PWM out will remain high or will keep the frequency constant. So for an example, let's say the result is brought in from the ALU as Y, and then threshold is calculated to be equal to X. For any value of the counter or the clock cycle that is less than threshold, PWM out will be equal to 1 or will be high. For anything greater than or equal to X, PWM out will be low or 0. So that means that PWM out is high for X over the counter variable, which in this case is 65,535, which is the highest value you can express with 4-digit binary. That means that that value, X over the clock cycle, is essentially the amplitude for the audio output.
Yeah, so I have a speaker, so we thought it would probably be cool if we use them in our lab somehow.
Yeah, we initially started with the idea of building a sequential Morse code output, but after spending many hours on over the course of several days, and we didn't get that much done. We thought we gave up. We decided to do a combinational circuit instead, that uses a monotone audio output that only changes in amplitude. So there's no pauses, no anything.
So we got this initial idea to somehow work, but
Yeah.
it didn't work for the other inputs.
Yeah.
So overall, we are pretty happy with the result, even though it isn't what we initially intended to
Yeah.
do.
Yeah.
Yeah, but
It's still like ultimately it still
Yeah.
accomplished the like general goal of representing a digital or binary output using audio, which
Yeah.
ultimately that's what we wanted to do, and we did it. So.